So dear 10th class students, today we are starting new chapter triangles. In this chapter triangles, our first point of discussion is similar figures and similar triangles. See, in early standards you learned congruent figures and congruent triangles. Two geometrical figures are said to be congruent. They are same in shape and same in size. So if two geometrical figures are of same in shape and same in size, they are said to be congruent figures. And you have learned what we mean by congruent triangles and various criteria for congruent triangles we have learned in early standards. Now, what do you mean by similar figures? See, two geometrical diagrams or two geometrical figures are said to be similar figures. They are same in shape but different in size. Same in shape and different in size. So this is similarity. Now when you say two polygons are similar, two polygons of same number of sides are said to be similar if the corresponding angles are equal and the corresponding sides are in proportion. This is a condition for two polygons of same number of sides to be similar to each other. For example, let us take two quadrilaterals ABCD and another quadrilateral I am taking PQRS. So these two quadrilaterals are similar if and only if the corresponding angles are equal. So angle A should be equal to angle P, angle B should be equal to angle Q, angle C should be equal to angle R, and angle D should be equal to angle S. So this is the first condition for two quadrilaterals. Thus quadrilaterals can be anything, two squares or two rectangles, okay, two rhombuses. So two quadrilaterals are said to be similar if their corresponding angles are equal, and the second condition is the corresponding side should be in proportion. That means ratio between the corresponding sides must be equal. That means AB by PQ should be equal to BC by QR should be equal to RS by CD. AB by PQ should be equal to BC by QR should be equal to CD by RS. Are you following? Should be equal to AD by PS. So the corresponding angles must be equal and the corresponding sides should be in proportion. That means ratio between the corresponding sides should be equal, like this. Are you following? So in such case, the two quadrilaterals are said to be similar. Did you understand these 2 points? Not only quadrilateral, any two polygons with same number of sides will be similar if and only these two conditions satisfied successfully. Did you understand? Now coming to next point is similarity of triangles. See here, similarity of triangles. So, two triangles are said to be similar. See triangle ABC. And another is triangle PQR. Triangle ABC and triangle PQ are said to be similar if angle A is equal angle P, angle B is equal angle Q, and angle C is equal angle R. The corresponding angles are equal. And second condition, the corresponding sides are in proportion. That means AB by PQ is equal to AC by PR is equal to BC by, are you following? AB by PQ should be equal to AC by PR should be equal to BC by QR. So these two conditions are satisfied, then the two triangles are similar. Corresponding angles are equal, ratio between corresponding sides are equal. So coming to next point is notation. See, in the previous context, we said triangle ABC is similar to triangle PQR. In that case, we use the notation triangle ABC is similar to triangle PQR. This is the right notation to express, but it should not be wrong. This is right notation. Now wrong notations also I am writing to make you clear. So the wrong notation is triangle ABC is similar to triangle QRP. If you have written, it leads to wrong. See, you should be very particular in mentioning the order. So it is most important in similar triangles. See, because angle A, angle P equal, angle B, angle Q equal, angle C, angle R equal in the previous context, whatever the diagrams we have drawn, in that angle A equal to angle P, angle B is equal angle Q, angle C is equal angle R. So when we are expressing the similarity, you have to express, this is the only way that you have to express. If you take little freedom to express triangle ABC similar to triangle QRP, maybe you are thinking triangle PQR, triangle QRP is same, but it is wrong okay, with respect to similarity of triangles. As far as area is concerned, order has no significance. Suppose if you are saying area of a triangle, then you can say area of triangle PQR or area of triangle QRP, your wish. But when you are expressing similarity, the order is most important. Please do understand. So this is wrong notation and this is right notation, and always good students follow the right paths but not wrong paths. So notation over. Now properties that similarity relation holds. Properties that similarity relation holds. First property is reflexive property. That is, every triangle is similar to itself. It is reflexive property. Please do understand this. Every triangle is similar to itself. This is reflexive property. So first property. Second property, if triangle ABC is similar to triangle PQR, it also implies that triangle PQR is similar to triangle ABC. This is called symmetric property. And third, triangle ABC is similar to triangle PQR, and triangle PQR is similar to triangle XYZ. Then triangle ABC is similar to triangle XYZ. This is called transitive property. So similarity of triangles successfully obey these three properties, and in future, okay, you can use them whenever you feel it is required to use this property. You can use without anybody's permission. Two triangles are similar to itself. If triangle ABC is similar to triangle PQR, implies triangle PQR is similar to triangle ABC, it's symmetry. Triangle ABC is similar to triangle PQR, and triangle PQR is similar to triangle XYZ, implies triangle ABC is similar to triangle XYZ. This is transitive property. Understood? So dear students, today we are going to discuss basic proportionality theorem, abbreviated as BPT. The statement is, if a line is drawn parallel to one side of a triangle to intersect the other two sides at two different points, then it divides the two sides in the same ratio. This is the statement of BPT. So this is a diagram. I took the diagram as triangle ABC. In this, the line DE goes parallel to BC, and this line DE is intersecting AB at D and the side AC at E. That's what I expressed in given. In triangle ABC, the line D is parallel to BC. D comma E are points of intersection of DE with the sides AB and AC respectively. Understood? So dear students, we have written the given of BPT. Now what we are supposed to prove? Then the drawn line D divides the two sides in the same ratio. That means AD by DB is equal AE by EC. The line which is intersecting the two sides divides the two sides in the constant ratio. That means AD by DB is equal AE by EC. That's what we are required to prove. Now the construction is most important. We have drawn EF perpendicular to AB, or you can say AD, your wish, and DG perpendicular to AC or AE, you can say, because all are collinear points. So this is what the construction. The second construction is, we have joined the points C and D and B and E. We have joined the points C and D and B and E. This is what the construction. Now proof follows. So in proof, just first we will confirm the equality between the triangle DEC and the triangle BED. Please observe, these two triangles BED and DEC are on the same base DE and between same parallels BC and DE. So as we have learned in 9th standard that two triangles are on same base and between same parallels are equal in area. So therefore immediately we can say that triangle BED equal to triangle CED. Reason, same base DE and BC parallel to DE. So that is the reason. Now keep that aside. Now you go for the ratios of areas of triangle ADE to triangle BED. So you know area of triangle formula, half into base into height. So area of triangle ADE is half into base is AD into height is EF by triangle BED half into base is BD, because if you produce BD, okay, you can see the perpendicular attached to it. So half into base is BD into height is EF. So then half of get cancelled, then you get AD by BD and this EF get cancelled. So triangle AD by triangle BD got AD by BD. You keep it aside. Now you go for ratios of the areas of triangle ADE to triangle ECD. And is here half into, now you take base as AE and height as DG divided by half into ECD base is EC into height is DG. Half of get cancelled, DG get cancelled. So AE by EC. So triangle ADE by triangle ECD equal to AE by EC. See, this is true. But already we have proved that triangle BED is equal to triangle ECD. Okay, these two triangles are equal in areas. So we have proved this result by using this theorem. Say this is the result star. Therefore, using the result in star, at once you can see that triangle ADE by triangle ECD is equal to triangle AD by triangle BED. Using the result in star, we get obviously this. And whereas we have proved this is AD by BD, so AD by BD, and we have proved that this is AE by EC. So AD by BD is equal AE by EC. Whatever we are required to prove, we have proved. Hence, basic proportionality theorem is proved. Now, dear students, we are discussing now converse of basic proportionality theorem. The statement is, if a line is dividing the two sides of a triangle in the same ratio, then it is parallel to third side. So I have drawn the diagram. So given in triangle ABC, the line DE is intersecting AB at D and AC at E such that AD by DB is equal to AE by EC. So it is dividing the two sides of triangle in the same ratio. Then part will come in RTP. Then it is parallel to third side. Then we are required to prove that D is parallel to BC. So dear students, we are going to prove the basic proportionality theorem proved by contradiction method. So you all are aware of what is contradiction method. In contradiction method, we assume that what we are supposed to prove is wrong, and we cling to some our own conclusion and will proceed further. Somewhere we meet with contradiction, so we'll realize that our assumption is wrong, and we'll say that the given is true. So this method of proving is said to be method of contradiction. So now I am assuming that my actual conclusion D is parallel to BC is wrong. So suppose D is not parallel to BC. Suppose D is not parallel to BC, then there should be some point L. There should be a point L different from E on AC such that DL is parallel to BC. So if you assume that D is not parallel to BC, then obviously there should be some other point L which is different from E such that, and this other point L which is different from E is on AC, and this point L is such that DL is parallel to BC. Okay, come what it may be, you accepted that DL is parallel to BC, then basic proportionality theorem come into the picture. The moment a line is parallel to third side, then it divides the two sides in the same ratio. Therefore, by basic proportionality theorem, we have AD by DB is equal AL by LC. By BPT we have but AD by DB is equal AE by EC by given. So then AD by DB, AD by DB equals these two must be inevitably equal. So therefore AL by LC is equal to AE by EC. Are you following? So now add 1 on both sides. Adding 1 on both sides, AL by LC plus 1 is equal to AE by EC plus 1. So if you take LCM, AL plus LC by LC is equal to AE plus EC by EC. Then AL plus LC gives you AC, AC by LC, AE plus, are you following? AL plus LC, are you following? Is equal to AC by LC is equal. AE plus EC gives again AC. Whole is the sum of the parts. So AE plus EC is AC. AC by EC. Then this AC get cancelled, and by cross multiplication EC is equal LC. As EC is equal LC, so E should be equal to L. Okay. So but we in the beginning we said E is not equal to L. Now you are getting E is equal to L. That means what you are getting, E is equal to L and E is not equal to L. Both you are accepting, which is a contradiction. A contradiction arised. Therefore, our assumption is wrong. Therefore, okay, DE is parallel to BC is correct. This completes basic proportionality theorem. This completes the converse of the basic proportionality theorem. Converse of the basic proportionality theorem.